our rise and run. So if we are looking at this one, we actually have, as we start off, to find our slope, M, we know, is rise over run. And in this case, we went from 150 down to 50. So what was our change? We could say it's a negative 100, right? You could have subtracted those two also. What is our run? Well, we went from 0 over to 5. So our slope in this case should be, what were we looking at? A negative 100 divided by 5 gives us negative 20. What's our y-intercept as I'm looking at this one, Haley? 150. And if we were going to write an equation for this, my equation should be y equals saying what x? Negative 20x plus what, Daniel? Plus 150. What does the 150 mean if I am looking at that? What does that 150 mean? It's what in her pool? If you were going to answer that question. What is that 150 mean in her pool? That's how much what? What do you think, Layla? How much water there was when we started, right? If I'm looking at the slope, what is that slope telling me, Adam, the negative 20? That each what? Each what? Each minute you're losing what? Each minute, what's happening to our pool? Is it going up? With a negative slope? Brett, what do we know? It's losing 20, in this case, gallons. So losing 20 gallons, right? Each minute. Okay? Yeah, you do. All right. Looking at this homework that you had for today. Questions. This is 11B. It's on the front and back of a page. Okay, I don't need you to take it out. I just need you to look at it. So, everyone turn to this in your workbook. If you didn't finish 11, I definitely need you to. We are going to be taking notes on 12. There's a couple videos with this. Questions. Anything as you're looking at this that you're not sure about how we write? So the symbol for congruent, we give you that. Yeah, correct.
The ones with like KOC for the bottom C.
So we're looking at
22.
Down here?
No,
on the second page. Okay. This first page, all of these, they tell us that this is the symbol for congruent, right? That equal sign with the squiggle above it, that's all of those are congruent, and you really the key thing is matching up the angles and the sides. When we take a look at this one, and we're looking here at this part, is this the one you want to look at? My hint would be if we think of drawing these two triangles, and if I draw, you have a big triangle, right? Which is from L to T to C. And then I have a smaller triangle, which is from K to O to C. And what we know is that this is 32 degrees in both of these pictures, right? We know that at angle L it is 73 degrees. And we know that our two triangles are similar, which means if they're similar, all the angles have to be the same measure. So if L is 73, and if I look at this, K is in the same spot, K must also be 73 degrees, right? So it's asking us, well, how do you find the measure of angle T? If I know these two angles, how many degrees total in a triangle? In one triangle, all three angles in a triangle, what do they have to add to both? 180. So I already know that I'm going to add 73 plus 32, right? That's going to give me 105. And if I want to subtract from 180, so now I'm going to take 180 minus 105. angle T has to be how many degrees? Angle T has to be 75 to give us 180, right? So I found angle T is 75. It says, well, what is angle if we are looking at this? O to K to C. So when they have the three letters, that means you're starting at O, you're going up to K, and then you're going to C. That had to be the same. This one had to be 73. And then this one says, well, what is KOC? So K to O to C. Well, this angle and this angle are exactly the same. They both have to be. So once you know the order, that kind of helps you to find those missing ones. So that should have been 75 also. So what did you think of the joke? Anyone want to read the joke on the first page? Anyone want to read that to us? Fair looking. What do we have for our joke on the first page? Go, Chloe.
The tickets were all square.
So why couldn't Virgo buy a round trip? Because the tickets were all square. The back page, does any animal have more than 9 lives? We should have had. Which one? Someone want to read it? That one? Ellie, what'd you get?
Yes, frogs croak every night.
Yes. Croak, like die, croak, croak every night. So, I want you to hang on to that for right now. A little later in class, we'll probably be getting your quizzes back. There's a lot of you there was a few people that didn't finish, and some of you, we might get those done in class today if there is time. Layla, I have a quiz that you haven't finished. Sophie's still here. Okay, so we just need to make sure we get those done. All right, so in your notes, we are going to be looking at how or why things are congruent. So we're going to pull up this video right now. And so you should be in your notes. And
how do you know if two things are congruent? In this lesson, you will learn to identify congruent figures by comparing their segments and angles. When we discussed translations, reflections, and rotations, we said that they were rigid transformations because no matter how we slid, mirrored, or turned the figure, it stayed the exact same size and shape as the pre-image. Congruent is another term in geometry which means having the same length, measure, or size. The symbol used when saying two segments, angles, or figures are congruent is this symbol. Looks like an equal sign with one small squiggle on the top. A common misunderstanding regarding congruent is thinking that two things with the same shape are congruent. These are both yellow lines, but they are not congruent because one is shorter than the other. These two right triangles have the same angle measurements and are the same shape, but one figure's segments are longer than the other figures, so they are not congruent. Two segments are congruent if their lengths are the same. AB is congruent to CD because they are each 3 units long. Notice how A corresponds to C and B corresponds to D. Two angles are congruent if their measurements are the same. Angle ABC is congruent to angle DEF because they both measure 45 degrees. Notice how AB corresponds to DE and BC corresponds to EF.
so using the 3 letters that you didn't
Two
separate.
figures are congruent if they are exactly the same size and shape. Notice how angle ABC corresponds to angle EFG, and they are both 80 degrees. Notice how segment DC corresponds with the length of segment HG. They are both the same length. In this lesson, you have learned to identify congruent figures by comparing their segments and angles.
So as we are looking at that, that's going to be kind of one of the things we look at. So as you're doing this one, so as we are looking at this and it says, okay, let's look at this picture. What does A have to correspond to? So A is in this picture. Where would that be? And if they tell us A, B, C, D has been moved so it fits exactly, P, Q, R, S. A matches up with, you would tell me which letter? A and what? A and R, right? So if I'm looking A and R, right? B should match up exactly with, so R to S. And what you can really do, which is kind of nice as you're looking at this, is you're just kind of going around that picture. So B is to S. So C has to be in the same spot as P, and D is in the same spot as Q. Okay? Now, the next part down is simply writing the segments that correspond. So, A to B, we want to keep it in the same order. AB should be segment RS. B to C should be the same as S to P. CD. PQ. Do you need to have that segment mark over the top? Yes. Because or else you are talking about a distance. So DA should be QR. So now look at the bottom. And shouldn't the bottom angles be exactly the same as what we had up here? So A, if we are looking at this, A is going to match up with angle, and you use the angle symbol in front, angle R. So this is almost exactly the same as what you had here. A to R, angle A, angle R. B should be with angle S. If you haven't filled all of these in, C to P and D to Q. Make sure you're using that angle symbol in front, okay? So when I look at yours, I should see exactly like that. So on the next page, on the top of the next page, you're looking at those turtles. And it says, if we look at all these turtles, what reflection, rotation, or translation, or combination will get each small turtle onto a congruent one, okay? So if we're looking at these turtles down here, what would you say to get if we call this turtle, let's call this one turtle 1, turtle 2, and turtle 3 of our 3 small ones, okay? So it says what reflection, rotation, translation, or combination would get one of the smalls onto the other one. So how about if I'm going from 1 to 3, turtle 1 to turtle 3? Please right now, talk to your shoulder partner. What do you think you're going to do? Reflect, rotate, translate, or combination to get 1 onto 3. Then we're going to talk about getting 2 onto 3, or 1 onto 2. So kind of discuss each one of those right now. Zach, what'd you guys say?
Translation.
Translation. So we would translate it. We're going to slide it to the right, and down. Right? Would you explain it that way? Okay. We went to the right and we went down. Okay. If I'm looking at 2 to 3, what am I looking at for 2 to 3? Sage Carmen, what did you guys come up with? Reflection. 2 to 3. Is if I reflect it, and I have a line here, right, for a reflection, I agree, it looks like I'm going to be reflecting it. Will it match exactly after a reflection? Reflection and then maybe a translate, right? So I probably have to do 2 for that one. How about 1 to 2 if I'm looking at that one? Ava, Brett, what did you guys say? Reflect and then translate. So if I do a reflection, I'm kind of reflecting it. Which way would you reflect? Over like a y-axis, thinking of this is my y, or an x? If I do an x, it's going to flip it upside down. Its feet are going to be up on top, right? So we should be reflecting, if we think of this, reflect over the y-axis, kind of, right? That vertical line, the y-axis, then we are going to translate. So in your homework, this is kind of what you're going to be asked to do. You're going to be asked to try and match figures up as you are looking at those, okay? So this one is saying, as you look at this next problem down in your notes, what combination of reflection, rotation, translation matches A, B, C, D up to P, Q, R, S? Now they don't give us a grid. Yours will have usually a coordinate grid. What would you say if you were looking at this? What does it look like we are doing to get like point A to come down to R? D is we are going, D is going to match up with Q. Anyone have any ideas? Raise your hand. What are you thinking? Reflection, rotation, translation. Rotation, I agree. Rotation, right? It looks like A has to come all the way over. It's turning. So would that be a clockwise or counterclockwise? Counterclockwise. And we don't even really know the number of degrees, but it's pretty easy if we look at this from A to B, and then that kind of ends up down here. So we could maybe say a degree, but we're just going to put rotation. All right. So in this next one, they're going to talk about these two figures in this next video. It's pretty short. As you are watching that video, I want you to kind of look at these two down here and try and think as you watch the video, are the two triangles congruent? Yes or no? And if so, how could you describe it? So as we watch the video for this part, I would like you to start thinking, how could I get these to match up? What kind of rotation, reflection, translation? Okay, so I'm going to put that other video up.
I don't have a ruler. I don't have a ruler and a protractor, but I need to tell whether two figures are congruent. In this lesson, you will learn how to show two figures are congruent by using a sequence of transformations. Let's review. We know there are three kinds of rigid transformations that keep size and shape the same: rotations, reflections, and translations. In a reflection, size and shape stay the same, but orientation and position change. In rotations and translations, size, shape, and orientation stay the same, but position changes. Is figure D congruent to figure B? Let's investigate by first just looking at the two triangles. I can't get to figure D using a single translation. I can't get there by using a single reflection, nor can I get there by using a single rotation around the origin. Is figure D the image of figure B after a sequence of transformations? First, we'll try reflecting over the x-axis. Can we get to figure D from this quadrant? We'll try with a 90-degree clockwise rotation, and it doesn't fit, so this won't work. We'll try a reflection over the y-axis. Can we get to figure D using another reflection over the x-axis? Nope, that doesn't work either. We'll try again. Let's try reflecting over the y-axis and see if we can get there using a 90-degree counterclockwise rotation around the origin. That doesn't work either. We'll try a rotation first. We'll do a 90-degree counterclockwise rotation. This looks good. If we translate 4 units down, we see it fits. Since we know that both rotations and translations leave size and shape unchanged, we know that a sequence of a rotation followed by a translation will also leave size and shape unchanged. If size and shape stay the same, these figures are congruent. We have demonstrated congruence by showing that figure D is the image of figure B after a sequence.
So in that one right below, you're going to say they were congruent. What did they do? 90-degree rotation. Which way? Counterclockwise, and then they did a translation. Okay.
Sequence of rigid transformations. Is figure F congruent to figure E? Looking at the two figures, we can see that figure F is not the image of figure B after a single translation, or a single reflection, and not after a single rotation around the origin. Can we demonstrate congruence through a sequence of transformations? We'll try reflecting over the y-axis first.
Is it going to work?
Then 180-degree rotation, and it's not going to fit, so this won't work. Let's try reflecting over the y-axis, and then reflecting over the x-axis, and then a 90-degree counterclockwise rotation, looking good. If we just translate 1 unit, we see that it works. Since all of these were rigid transformations, none of them changed.
So that one had a lot, right? Could you do it simpler?
Yes.
So when you do this test, when we take this test and we're working on this, you're going to see as you go to the back and the answers in the back, the one answer that they give you is not the only way to do it, right? Because someone else could have said, you know what? I would have maybe rotated this 180 degrees. Would that work? If I would have done that right away, did 180 instead of the reflect Y, reflect X, that gives me the same picture. And then I rotate again and then I translate. So there is more than one way of doing this, is what I kind of want you to just be aware of as you are.
Change the size or shape of the figure. We've demonstrated that figure F is congruent to figure E by using a sequence of transformations. We used a sequence of reflections, rotations, and translations to show congruency. A common misunderstanding is thinking that there's only one sequence of transformations that will demonstrate congruence. This sequence uses a 90-degree clockwise rotation and a 1-unit translation to the right to show congruence for the same problem that we solved using 2 reflections, a rotation, and a translation. In fact, there are multiple ways to get to the same result using different sequences of transformations. Try and see if you can think of another way to achieve this result besides the 2 ways we just showed. In this lesson, you have learned how to show 2 figures are congruent by using.
So we came up with a different one than the ones they did. I want you to turn in your notes right now to this page. Do these 2 look congruent? The length of the sides. This one is a 3 by 3 here, and notice this is kind of like 3 by 3 if I'm looking at that. So this length, using our Pythagorean theorem, we could have found that from C to T is the same as P to K. So if we are thinking about this, are our figures congruent? Yes, we would say they probably are. How do you think we can get them to match up? Anyone have any ideas if we are looking at this? What do you think, Dave?
Rotating 90 degrees counterclockwise.
Okay, go 90 degrees counterclockwise. Now, if we think about what does that do to our points? XY changes to, again, this is where this is going to be helpful. I'm going counterclockwise. So I should put what, Raya? Okay, so Y and negative X or negative Y? Negative Y, so pointing to that one. So if I look at the point T, right, and I want to say that, okay, T was located at negative 1, 6. If I'm doing this rule, T prime, if I was doing that, T prime should be located at negative 6, 1. Negative 6, negative 1. Did it end up there for our point P? It ended up exactly there, right? So this is exactly just one sequence, right? How did we get? We can say triangle TCW is congruent to triangle. Please write it out like this. Triangle. What matched to T? P. What matches to C? K or M? On this picture. K and M. It is very important that your letters are in the right order, okay? If you start at T, T matched to P, we got to make sure they're in the same order, okay? I want you to take a look at, so in your homework, there's going to be some where you're just doing one thing, some you're doing many. If you would turn in your workbook right now, in your workbook that you're going to be looking at, it says identify corresponding parts. Notice that if you would cut them out and place one on top of the other, they line up or correspond. I will tell you down here, please take a look at number 6 and 7 in your homework. Right, so we are on H12. Okay? 6 and 7 on the bottom of that page. What are these markings telling you? They are telling you what sides are the same length for the sides. They're telling you these angles are the same. Okay? So it says, if they are congruent, explain how you would write the congruent statement. Okay? So, if you start at M, where do I have to start on the other figure if I'm looking at number 6? I start at M. On the other figure that looks congruent, I have to start with what letter? P. And then you got to give the other 2 letters, and then you just got to make sure you match up. So if you notice in this one, A has a single mark, you got to have A, D match up with the letter A. They have to be in the same order, okay? There is really only one that I think is kind of weird, and that is number 10. And the only thing we have done is reflecting over the Y and X axis. And I want you to look at number 10. In number 10, what does it look like they are doing to get from figure A to figure B? There's 2 things, right? What's the first thing, Daniel?
Reflection.
Reflection. But we're reflecting it over this line right here. Now, if it's a vertical line, what we want to put down is we are going to reflect it over X, not the Y axis, but X equals 2. And my hint is I would draw that if I were you. Right? So if I'm looking at this picture, it kind of comes down to the middle here like this. And then what's the next sequence to get on to the next one? That would be my hint to you. Okay?